Applied Mathematics Chapter 9 Function. Algebra of real function. Let f such that x to real number and g is another function from x to real number. Then f and g be the two real functions such that x is a subset of a real number. Then we say that the sum of the two functions f and g, f plus gx is given as fx plus gx for all x belongs to x. And difference of two function f minus gx is given as fx minus gx for all x belongs to x. Product of two functions given as f into gx is equal to fx into gx for all x belongs to x. And the quotient of the function is f upon gx is equal to fx upon gx for all x belongs to x, provided the denominator gs should not be equal to 0. And reciprocal of the function 1 upon f is given as 1 upon f is the reciprocal of the function f, then 1 upon fx is given as 1 upon fx for all x belongs to x, provided that fx is not equal to 0. Composition of function. Let f and g be the two real valued function and d is such that x belongs to the domain of f and fx belongs to domain of g is not equal to 5. That means domain is not an empty set. Then we say the composite of f and g denoted by g of f is given by g of fx is equal to g of fx with domain D. For example, we say that the function fx is equal to 2x plus 5 and gx is equal to x square plus 1. Then f of gx can be calculated as f of gx. That means wherever there is a x in the function of f, we substitute the function x square plus 1, the function of gx. So here we have 2x plus 5. So I will write 2. Instead of x, I will write the function gx as gx is there. So I will write x square plus 1 plus 5. On solving, I get 2x square plus 2 plus 5, which is equal to 2x square plus 7. So f of gx is equal to f of gx, which give me the result as 2x square plus 7. G of fx is equal to g of fx. That means wherever there is a x in the function of g, in the function of gx, wherever there is x, I will substitute the function fx. So x square means the function this 2x plus 5 whole square plus 1. Now x has become the function g fx. So instead of x, I will write the function fx 2x plus 5 whole square plus 1. On solving, I will get a plus b whole square, a square plus b square plus 2ab plus 1, which is equal to 4x square plus 20x plus 26. Again, f of fx, that means f of the function fx. So in the function of fx, I will substitute, instead of x, I will put the function fx itself. So 2 times the function fx itself, 2x plus 5. Because here x, instead of x, I will have to put the function fx, which plus 5. On solving, I get 4x plus 20 plus 5, which is equal to 4x plus 25. Now g of gx, it gives me that's g of gx. So wherever there is x in the function of gx, I will put the function gx itself. Here I have x square plus 1. X, instead of x, I will put the function x square plus 1. So I will write x square plus 1 whole square plus 1. Instead of x, I will put the function x square plus 1. And since x is square, so I will write square also. X square plus 1 whole square plus 1. So open the bracket with a plus b whole square identity. I get x4 plus 2x square plus 1 plus 1, which is equal to x4 plus 2x square plus 2. G of gx is give the result as x square plus 2x square plus 2. If fx is a function x cube plus 1 and gx is a function x plus 1, be a two real valued function, find f plus g, algebra of a function, f plus g, g minus f, f into g, and f upon gx. F plus gx could be written as fx plus gx. That means if we add the two functions, we will get f plus gx. So here we have x cube plus 1 plus x plus 1, which is equal to x cube plus x plus 2. So f plus gx is x cube plus x plus 2. G minus x fx. That means we have to subtract gx minus fx. G or minus f means first function is gx minus fx. So gx is minus x plus 1 minus x cube minus 1, which is equal to x minus x cube. Product of the function f into gx, that means fx into gx. Fx is my x cube plus 1 and gx is my x plus 1. So multiply this, x4 plus x cube plus x plus 1 is the my result. X cube, x to the power 4, x cube plus x plus 1. Because further it is not simplified, so we will get the result this only. F upon gx, that means the function fx upon gx. So fx function is x cube plus 1 upon gx function is x plus 1. Now we know that denominator should not be equal to 0. So we can say that this is the function provided x cannot take the value as minus 1. Because if x takes the value minus 1, the denominator becomes 0 and function does not define. So we will stick with that x can take all the values except minus 1. If fx is a function as x cube plus 7 and gx is a function 3x plus 5 be the real function, find the value of f of 3 plus g of minus f. First of all, we calculate f of 3, then we calculate g of minus 5 and then we add. So f of 3, wherever there is x in the function, I will put 3. So I will get 3 square plus 7. I consider function x cube plus 7. So instead of x, I will put 3. This give me the result as 9 plus 7, 16. G of minus 5. G of minus 5, the function of gx is 3x plus 5. That means 3 times minus 5 plus 5. Minus 15 plus 5 is minus 10. So add these two. F of 3 plus g of minus 5 is equal to 16 minus 10, which is equal to 6. This is my answer. Again, f of half into g of 14. First of all, I calculate f of half. F of half means in the function of fx, I put half, x square, half square plus 7. That means 1 by 4 plus 7, which is equal to 29 by 4. G of 14, 3 times 14 plus 5. That means 14 3s are 12, 1, 42 plus 5, which is equal to 47. Now I have to take the product. Product means f of half into g of 14. That means 29 by 4 into 47. 29 by 4 into 47. Simple, multiply these two. 47 into 29. 63, 6, 36 and 6. 42. 14, 1, 9. 3, 6, 13. So 1, 3, 6, 3 divided by 4. So the result of f half g14 is 1363 upon 4. The function fx is given as x cube minus 1 upon x cube. Prove that fx plus 1 upon x is equal, f of 1 upon x is equal to 0. First of all, fx plus f1 upon x. I will calculate for fx. Fx is the function itself. That means x cube minus 1 upon x cube. And what is f of 1 upon x? Wherever there is x, I will put 1 upon x. So I will write plus, instead of x, I will write 1 upon x. 1 upon x whole cube minus 1 upon, instead of x, I will write 1 upon x, 1 upon x whole cube. On solving, x cube minus 1 upon x cube plus 1 upon x cube minus 1 upon x whole cube means 1 upon 1 by x cube. X cube, 1 upon x cube plus 1 upon x cube. This cancel out. I get x cube minus x cube because 1 upon x cube, the reciprocal of 1 upon x cube is x cube. So x cube minus x cube is again 0. So we get the result as fx plus f of 1 by x is equal to 0. This is what I have to prove, hence proved. This is I have to prove that fx plus f of 1 upon x is equal to 0. So I proved it that it is equal to 0. A function fx is given as 3x minus 2 upon 2x minus 3. Prove that f of fx is equal to x provided x is not equal to 3 by 2. First of all, we calculate f of fx. So we get f of fx can be written as f of fx. That means wherever there is x in the function of fx, I will put the function fx itself. So that I will get 3. Instead of x, I will write the function of fx as 3x minus 2 upon 2x minus 3. Minus 2 denominator 2 times, again instead of x, I will write the whole function fx, that is 3x minus 2 upon 2x minus 3 minus 3. Now take the LCM and solve it. I will get 3 times 3x minus 2 times 2x minus 3 whole divided by 2x minus 3. Again 2 times 3x minus 2 minus 3 times 2x minus 3 whole divided by 2x minus 3. This cancel out. Multiply the numerator. I get, it becomes 9x minus 6 minus 4x plus 6 divided by 6x minus 4 minus 6x plus 9. On solving, I get 5x divided by 6 cancel out, I get only 5. So 5x upon 5 is only x. This is what I have to prove, that f of fx is equal to x, and hence I proved it that f of fx is equal to x. Hence proved. What I did, I simply substitute the value of fx in the function x. X is given to us, fx is the function given to us. Instead of x, I put the function fx itself. And then on solving, I get the result as x to prove that f of fx is equal to x. I hope you understand the algebra of function, composition of the function. So keep like my video and keep watching and subscribe my video.